Hello everyone, this is Tom Uren and I'm here with another Risky Business News sponsor interview. Today I have with me Feross Aboukhadijeh, the CEO and founder of Socket. G'day Feross, how are you?
Doing good, Tom.
Now Socket, you make, is it software that validates and checks open source software packages? Is that right? Is that a rough description of your company?
Yeah, that's right. So we help companies detect and prevent zero-day software supply chain attacks in open source software.
Okay, so obviously open source software has been in the news recently because of the xz supply chain attack, where for people who haven't heard about it, it looks like a state group over a couple of years ingratiated themselves with a maintainer and became trusted enough to become co-maintainers. And as soon as they were in that trusted position, they pushed out a backdoor, which ultimately, through a kind of chain of circumstances, backdoored SSH. And so the interesting thing to me is if you're willing to spend the time and put in the effort, you can get into that position just by being effectively a good open source citizen. Like they offered to help the package maintainer, they did help, they did work. And so that seemed like a very insidious form of attack. Now, you were telling me, Feross, that you started your company, you were inspired by, like, I guess kind of a similar incident back in the day?
Yeah, that's right. So there was an incident back in 2017 that has a lot of parallels to xz-utils, and it's actually kind of eerie, the number of similarities. It was an attack against a package called EventStream, and EventStream was quite a popular package. It had 5 million plus weekly downloads. And it was written by a maintainer who's a very prolific individual. He had about 500 packages that he authored.
Wow.
So, you can imagine some of those weren't very well maintained or potentially, let's say lightly maintained.
Yep.
But, he's a very, very generative person. He actually had moved on from this package that he wrote, and he made kind of a better version that he was actually maintaining. But someone came along to him and said, hey, we're using this EventStream package at my company, and we noticed you haven't updated it in a few years. I'd be happy to help out. And he said, sure, this is great. And added that person, gave them NPM publish rights to this person. And for about a month, they did normal changes, totally reasonable maintenance tasks. Mm-hmm. But then they added a new dependency that wasn't there before. And then that dependency itself had a couple versions of it that were published with malicious code added. And one of the things they did was they made sure that the code on GitHub and the code on NPM, they were different. So there's no guarantee that those are going to be the same. So anyone who looked at the code on GitHub would have just seen normal code. And this was targeting a specific company's product that they wanted to get into. And they had done their research and figured out that this was a dependency that was used by that product. The product was an Electron app, so it had a ton of these NPM dependencies. And they just picked this one because it seemed like a low-hanging fruit. It wasn't maintained. And they probably even tried asking a few other folks. Who knows, right? And this was the one that bit. And this was on NPM for about 7 days before the community was able to identify it. And during that time, it got built into the product that the company shipped to their users. It became part of one of their builds of their binary, and it went out and it affected users. It turned out it was a crypto wallet, and it stole a bunch of money from the users of it and all that kind of stuff. But yeah, I think one of the most amazing parallels was the way it was caught.
Yep.
It was totally accidental. So similar to xz-utils, right, where this issue was discovered by an engineer finding that their SSH login was taking 500 milliseconds longer than they expected.
That's right. That damn half a second.
Yeah, you got to love the kind of those nerds out there that, and I say that with an endearing tone in my voice, hopefully you can hear, that just pay that close attention to their dependencies and can actually notice, hey, I updated my dependencies yesterday and my SSH got half a second slower. So yep. Yeah, in the case of EventStream, it was a total accident. So what happened was that the attacker, some of the code they wrote, one of the functions they used was deprecated a few days later in Node.js. And so they didn't know that this function was going to be deprecated. It was deprecated, and then anyone running the bleeding edge version of Node started to see a deprecation warning in their console, and they traced it back to this dependency that had this extra code added into it. And once you look at the file there, you can just see, like, okay, what is this extremely obfuscated chunk of code doing at the bottom of one of these files? It just stands out like a sore thumb. But what blew my mind about this whole thing was, like, how come no one saw this for a whole week and it took this deprecation warning in the console to find it? Mm-hmm. And that was what really drew my attention to this whole supply chain security space and the problems we have. It's like no one's actually looking at this code, you know?
Yeah, that's right. And so what does Socket do about that kind of problem?
Yeah, I mean, so we started to see a pattern of these types of supply chain attacks, mostly targeting the NPM and PyPy ecosystems.
Mm-hmm.
And so we started off the product by actually just enumerating the list of things that could have caught the attack in an automated way. So, for example, with that event stream attack we just discussed, it was a very high entropy piece of code that was added to that file.
Right.
And so when you see that, why is there a diff where you see a ton of entropy added? That's clearly obfuscated, right? So that's like one signal. And we went through and we just came up with a whole bunch of these signals, right? Obviously, new maintainer without a history, the introduction of network access, shell access, child processes being spawned, this type of thing. And whenever you see that being added into a dependency where it never was present before, that's a huge red flag.
Right, okay. So you went from actual attacks that you heard about or learnt about and then figured out in that attack, this would have been a signal, therefore we'll stick it in our socket machine or whatever.
Exactly. And so we replicate all the open source packages in all the ecosystems that we support.
Mm-hmm.
We have a copy of them and then we follow the feed. So whenever new versions go out, we are notified within a couple of seconds, and then we download that code and then we do the static analysis of the code, pulling out these signals. And then when enough of those are present, then we kind of kick it over to phase 2, which involves a deeper analysis. We actually use LLMs, believe it or not, to help just tease apart like what could this code be doing and to make an initial determination as to whether or not it's malicious. So we sort of think of the AI or the LLM step as kind of like an initial triage. It's basically as good as an intern, really.
Right. Yep.
It's sort of, and then that produces a final feed that our human research team then looks through and can make a final determination on. And so we're finding today about that process I just described is identifying about 100 software supply chain attacks every week in NPM, Python, and Go, just those 3 ecosystems.
Yeah, right. And I kind of think that these kind of attacks, there's sort of 2 categories. There's the financially motivated criminal type where it's, I'll do the simplest, dumbest thing that'll work, and it only has to work for, a few days or a week perhaps to get me money. And then there's the state-sponsored ones, which are probably longer, slower, and they would like them to endure, I would guess. Do you have any sense? Are you just seeing a whole heap of criminal ones and maybe a few state ones? Do you have any sense of that?
Yeah, I think that's right. So there's a whole bunch of low effort attempts, and then there's a smaller number of very sophisticated attempts. So they vary in effort because a lot of these registries, they're basically open wikis. I mean, anyone can put anything up there that they want to put there.
Mm-hmm.
And so you do see just a lot of spam and low effort stuff, and hoping that someone is going to typo an install and just land on similar to domain name typo squatting. It's actually much worse with package managers because the typo there leads to remote code exec in a lot of package managers because you can often add an install script that runs automatically at installation time. And that can just immediately own your machine before you've had a chance to quickly hit Control-C to try to stop it. So yeah, I think you're absolutely right. Just in terms of volume, there's a lot of this like lower effort, financially motivated supply chain attacks.
And what are the sort of attacks where you go, wow, that was really impressive? Do you have a laundry list of those? Are you sort of keeping them in a best of collection as you go along?
Yeah, I mean, I'm always impressed at the types of obfuscation people attempt to use because they know that folks are looking, now that Socket exists and there's a few others, they know that folks are looking for these patterns. And I think a lot of companies are doing simple things like just running a regex over files and looking for certain words. By the way, speaking of which, you can actually get pretty far with that approach. We see so much malware being hosted on the Discord CDN. So if you have a package that has nothing to do with Discord and you find the word Discord in the package, that's not a good sign. But there's lots of ways people try to hide to prevent certain strings from just appearing in the source code, and those are always impressive. But I have to say that one of the best uses of LLMs in that case is if someone attempts to avoid static analysis, being able to just show the code, even if it's not as good as a human, but being able to just show it to an LLM and get a reaction to what the code looks like and does it look normal, that actually can go really far because there's lots of ways to make network requests, like in a JavaScript, or let's say a browser context, for example. You can set a background image, on a random DOM element. There's lots of different ways to exfiltrate data. Let's say we've missed a few ways in our static analysis, for example. Showing that to an LLM, that can actually identify that often, right? It can just say, okay, that is what it's doing, or that looks weird. That doesn't look like normal code. And so we also use it as kind of a backup for when the static analysis fails, and it can flag things for further analysis. And so that's really the value of what we're trying to do at Socket is, in an ideal world, every developer would vet their dependencies and would read every line of code of their dependencies.
Yes.
But it kind of defeats the point of open source if you're doing that, because you're trying to get the benefit of like abstraction, and I shouldn't have to know the details. That's why I'm using this package. So I've talked to some companies that do actually treat every dependency as their own code, and they check it in and they own it in that sense, but it's pretty rare. Most teams,
it's got to be a lot of work, doesn't it?
Of course, yeah. I mean, it's like something like 90% of the lines of code in an app are open source dependencies. So you're looking at like a 10-to-1 ratio. But what's funny about that is that weirdly, most teams, they have some type of a code review process for their own teammates' code. Usually you have to have at least one, maybe two reviews before code can get into the code base. But when it comes to dependencies, typically that shows up in GitHub as a diff that just says, oh yeah, this version changed, version 2 instead of version 1. And it looks like a simple, innocent one-line change, but that could be masking, potentially hundreds of thousands of lines of actual code that's changing in those dependencies. That happens. Right, yeah. And those never get evaluated. I mean, the tooling doesn't make it easy, and no one is really looking at that. And that makes it really easy for attackers to use open source as a vector for these attacks.
Yeah. Now, in the XZ case, there was quite a lot made of the fact that there were, I guess, sock puppet accounts. So there was a single maintainer, and it seems like having a single maintainer makes you vulnerable to people offering to help. Vulnerable, air quotes. And there were also sock puppet accounts that tried to apply pressure. And subsequently, some of the warning posts said things like, here's an indicator that you're being played, is that there's people suddenly appearing and complaining about your packages. But that struck me that might actually just be totally normal in the open source world. Do you have any ideas about that? Thoughts?
Yeah, I have thoughts. So I've been an open source maintainer for a very long time, probably going on 10 years now. And I was early in the Node.js community and then kind of wrote some popular packages in that world. And let me tell you, people come onto your issue tracker and open up issues all the time that's with the title, "Is this project dead?" And it's the most infuriating issue to get, because you're putting all this effort, your heart and soul into this project, and you're fixing issues and you're merging pull requests and you're trying to just stay afloat. Yeah. I like to call GitHub issues like it's a globally writable to-do list that anyone can just add to-dos to your day until the maintainer wisens up and realizes, hey, I actually don't have to do all this work. But a lot of folks, when they start out, is they're just so excited to have anyone using their code, right, that they're just like, oh, an issue. This is amazing. I get to fix this bug for this Google's using my code, or this company's using my code. How exciting! And so it's very normal to have people complaining in the issue tracker. A lot of the stuff that happened here with xz-utils, it was a well-run operation. Each of the things that happened on their own happen all the time in open source. Yeah. It's nothing was odd. I mean, people complaining, people saying, hey, you should maybe get help. Hey, I can help, that type of thing. It's totally normal. And open source packages transfer ownership all the time. That's actually open source working correctly, right? I mean, you should be adding contributors over time. In fact, it's a sign of health of a project is that you have a lot of pull requests and you're promoting some of those contributors into full-time maintainers. It increases the resilience of the project. And you have this interesting kind of dichotomy, or I think of it, it's like it's a spectrum where the more maintainers you have, the more likely the thing is to get maintained, which is good for fixing vulnerabilities and being responsive to security issues that come up, and just good for overall quality and health of the project. It's no good to be depending on a package that's abandoned. And so additional maintainers can help prevent the project from getting abandoned. And if one person gets burned out, the other person can step up, right?
Yep.
But then if you kind of add too many maintainers, then you have a risk from one of them getting compromised and then that being a vector into the package. And if you have too few maintainers, you have burnout, and then that's a vector for compromise. So it's very hard to win.
So I was wondering if in your time involved in open source, you've noticed any changes that would make the ecosystem more or less vulnerable to these sorts of, I guess, trust-based attacks?
Yeah, so in the last 5 or 10 years, the way that we write software has undergone a really big shift. And today it's really common to see applications where most of the code comes from open source and you have this deep dependency trees. In NPM, the average dependency has 79 transitive dependencies. So you bring in one dependency, you bring in a lot of other dependencies are coming along for the ride. And so in a world where you have applications built on that many dependencies, security is not just about your code, it's about every piece of code that you're depending on. And so what we've seen really change is, it honestly started with NPM, and we've seen new package managers that have followed actually adopting similar practices. So things like Rust's Cargo package manager, they have this culture of many, many small packages. And some of that was actually coming from a good place. There's this idea of, the Unix philosophy, right? Do one thing and do it well. And so there was this kind of cultural aversion to these mega packages that just do everything and have a ton of functionality. The idea was, why don't you just choose something that just does exactly what you need? It's less surface area for attack. It's more focused. And so you ended up with this culture in Node and now Rust and newer ecosystems of just doing one thing and doing it well with small packages. One of the reasons that happened is because that package manager, NPM, actually solved a pretty difficult problem for developers, which is this problem of dependency hell. Mm-hmm. Dependency hell, what it used to mean when people talked about that was this idea that you could install dependencies in your app and they could get into a place where you couldn't really resolve them. So like, say that I had a dependency on foo, and foo depends on bar version 1, and then I now want to go install bar version 2 in my project. A lot of package managers just throw up their hands and say, well, you can't have bar version 1 and bar version 2 in your project. That's a problem, and you have to go and fix it. And a lot of times that's not even fixable from the developer's perspective because it's in a deeply nested dependency. So it creates this really terrible situation called dependency hell. And so NPM solved this problem by just saying, hey, let's just install both versions. Just install everything. And then if you ask for bar version 2, you'll get version 2. If a dependency wants bar version 1, it'll get bar version 1, and it'll just mostly work. And what that did was that created a situation where the cost to adding dependencies went to zero, because now I'm no longer worried about creating this dependency hell problem for my end users. I can just add as many dependencies as I want, and it feels like it's costless, right? To me, that's a moment where there was a really big shift in the way that we do open source. And so that, and there was one other big change too, which is the type of governance of projects changed. So it used to be, you might have 20 dependencies in your application, and they were things like Apache web server, right? PHP, Linux, jQuery, these big singular dependencies that do a bunch of things, and they're usually published by a foundation or some type of organization that you can trust. And what happened is, with the shift to the smaller packages, you move to a model where you have, instead of one package with dozens of maintainers, you have the inverse now. So you have one maintainer with dozens of packages, maybe hundreds of packages, right? So you have these individuals with just a ton of control over a lot of dependencies.
That's been a fascinating discussion, and you can find Socket at socket.dev. Feross Aboukhadijeh, CEO and founder of Socket. Thank you.
Thanks for having me, Tom. I appreciate it.